Okay, students, welcome back to one more video on basic statistics for biostatistics as well as medical statistics. Now, in this video, we are going to discuss about the next chapter of the basic statistics, that is diagrammatic and graphical presentation. That is diagrammatic, diagrammatic and graphical presentation. The thing is, main motto of studying this chapter, why we need diagrammatic and graphical presentation. Already we discussed which topic in the previous videos. Already we discussed about tabulation, right? So tabulation is nothing but frequency distribution, right? Tabulation is nothing but frequency distribution. But when you consider the definitions, both are different. Tabulation is nothing but a representation of the data in the form of rows and columns, right? So rows as well as columns. That is the tabulation. Then when you consider the definition of frequency distribution is a reorganization or organization or systematic presentation of the data in the form of tables. So likewise, here we have three types of frequency distribution. One is categorical frequency distribution. Categorical frequency distribution. One more, we have discrete frequency distribution. Discrete frequency distribution. Then we have continuous frequency distribution, right? So I told you whenever which distribution, I mean, which frequency distribution is going to use, right? So categorical, to represent the different categories of the data. Say, for example, for any number of patients, if the one of the treatment is given and the feedback or opinion collected by those patients, like such as good, very good, poor, very poor, likewise. So represent such different categories of the data. We have the one of the technique in frequency distribution, that is categorical frequency distribution. Then when we are going to use the discrete frequency distribution, whenever we have the quantitative data, right? Quantitative data, at that time we are going to use discrete as well as continuous frequency distribution. Anyhow, we have these are nothing but presentation techniques only, right? Frequency distribution is nothing but presentation presentation technique, right? We have one of the greatest and one of the simplest, easiest technique, that is frequency distribution. Anyhow, we have the frequency distribution technique. Although why we need this study of diagrammatic and graphical presentation, what is the objective or what is the purpose of studying the diagrammatic and graphical presentation? Is very simple. Here, one line is there. For statistical minded persons, their peak eye reading, right? It means that what, who knows the statistics, who knows the frequency distribution, that is okay. They can grasp the data very easily. But what about non-statistics people, right? But what about non-statistical minded people? Say, for example, who don't know the statistics or who don't know the basic knowledge of statistics, how they are going to analyze the data, how they are going to understand the data. Is it clear? So they are going to understand the data or they are going to analyze the data with the help of diagrams and graphs. Is it clear? So they are going to analyze the data with the help of diagrams and graphs. The main motto or the main objective of studying, sorry, the main motto or main objective of studying the graphical or diagrammatical presentation is uh, to represent the data in the form of diagrams as well as graphs, because of who don't know the knowledge of statistics. I mean, for non-statistical minded people, for them to analyze the data, to understand the data, and understand the data in simplest format, in easy format, we require graphical as well as uh, diagrammatical presentation, right? Then we have certain rules. We have certain rules while constructing the data or while, sorry, not data, while constructing the diagrams and graphs, right? So we have certain rules while constructing the diagrams as well as graphs, right? So then what are those rules? First rule is title, right? Every diagram should be given a title. Every diagram should given a title. Whichever diagram you are going to draw, you must give the title, right? So and the title indicate the main theme of that diagram. What is the title means? What the title or heading is going to represent, or that a title is going to give the or title is going to indicate the main theme, right? So main theme of the diagram or main theme of the graph, and it is always placed at top of the diagram. It is always placed at top of the diagram. This is the first rule. Then second rule, scale, right? So whenever we have higher data, say for example 5,000, 10,000, at that time we can't represent the data on a single paper. Suppose this is our paper or this is our working space. Say I can't represent the data up to 5,000 or 10,000. For that we are taking proportional. We are taking what? We are taking proportional data, right? Proportional data to why we are taking the proportional data means what? Because of to fit in the given space or to fit in the given area, it is very necessary to consider the scale, right? And while consider the scale, see, I don't know, the diagrams should be fit within the paper or within your working space. So that purpose we need to consider the scale. So therefore, proper scale should be taken. That diagram look attractive, right? So you should consider. I mean, you should consider the scale in such a way that the diagrams look attractive, right? Is it clear? The width as well as height of the anything, any diagram or any graphs should be look attractive in such a way that you should consider the scale. Then third rule, simplicity, right? The diagram should be very simple, because the main motto of presenting the data with the help of diagrams and graphs, because to understand and as well as to avoid the complexity in the data. So your diagram should be very simple. Means what? After observing the diagram, anyone they can analyze, they can understand the data, which is increasing, which factor is decreasing, or which parameter is increasing, or which parameter is decreasing, right? And don't overload the contents in your diagram as well as graphs, because when you overloaded the contents or when you overloaded the data in the diagrams or graphs, means the main objective is failed here. Is it clear? The diagrams are not suitable, I mean, not simple, right? So as much as you try to represent the data in very simple manner. Then fourth rule, neatness. Diagram should be very neat and clean. Diagram should be very neat and clean. So whenever you are learning biostatistics or medical statistics, obviously students are either undergraduation or post-graduation. So I hope that whatever you are going to present the data, it should be very simple as well as neatness. Then the fifth rule, that is index and footnote. See here we have two factors here. One is index and one more is footnote. So first, index should be used to show the meaning of different shades and the different shades and designs. Say for example, this is our diagram. Say for example, this is our diagram. See here we have these different bars. Here different bars, right? So which bar showing which data? For that, I can take some different colors here. So one is I will consider one color, say yellow, right? So and next bar should be filled by some sky blue or blue, and last is black. Is it clear? So here I represented the three bars, and those bars are with some different colors. Right. This is what indexing. See, indexing means what? Index should be used to show the meaning of different shades. Right. So it means that I can use the shades here. See, yellow means what? It representing the parameter one. Sky blue or blue means what? It representing one more parameter, and black is representing one more parameter, like that. Right. So index is nothing but index are going to be used to distinguish between the data sets. Then we have footnote. Footnote can also use it if necessary to write a note on a diagram, right? Suppose you want to give the conclusion on the diagram. Suppose I want to give, okay, yellow color is very less and sky blue is medium and highest is black color. Suppose I want to give the note, right? So I can give under the heading of footnote, right? Footnote is nothing but if you want to give the any conclusion or there are some space, that is called footnote, and it is always placed at bottom of the diagram, right? So footnote always placed at bottom of the diagram or graph, right? So footnote is always placed at bottom of the diagram or bottom of the graph, right? So these are the five rules are there, right? So five rules are: first is title. The title should be indicate the main theme of the diagram and it should be always placed at top of the diagram. Scale is because of the large data set, we need to take proportion size. For that, we need to consider the scale and simplicity and neatness, right? The diagram should be very simple and the diagram should be very neat. Index and footnote. Here, index is nothing but to show the different meanings or to show the different data sets. We are shading, we are filling the by color, or we are assigning certain different symbols, say plus, minus, into, divided by, like that, or we are simply shading with the pencil and all by manual method. That is called index. And footnote is nothing but footnote is like a note or conclusion on a diagram, and which is always placed at bottom of the diagram. So we have, these are the five rules. While I mean, we must and should consider while constructing the diagrams and graphs. Next is we have some different types of diagrams, right? The next is we have different types of diagrams, right? So in statistics, we have five types of diagrams. Those are one-dimensional, two-dimensional, three-dimensional, pictogram, and catogram, right? One-dimensional diagrams are nothing but those are one-dimensional diagrams are nothing but the diagrams always in only one direction, right? Diagrams are always in only one direction. Say, for example, here, either it should be vertically or it should be horizontally, right? So, like this. So, diagrams are always in one direction. That is what one dimensional diagram. Then, diagrams are in two dimensional. If the diagrams are in two dimensional, okay, for example, here, sorry, I forgot to give the example. For example, we have here bar diagrams, line diagrams, right? For example, one dimensional bar diagrams. Bar diagrams are nothing but I think you observe such types of bars. This is what bar diagram. And line diagrams means what? Like this. This is what line diagram, right? So here we have as usual basic x-axis and y-axis. Here also x-axis and y-axis. So whenever the data is represented with the help of bars, that is what bar diagram. And whenever the data is represented with the help of lines, that is what line diagram. So these are the different kinds of one-dimensional diagrams. Next is two-dimensional diagrams, right? So what do you mean by two-dimensional diagrams? Two-dimensional diagrams are nothing but they have two directions, right? So here they have two directions. What are those directions? One is width, and one more is length. We call height also width as well as length. Say for example, square, see, square, rectangle, rectangle, right? So likewise, we have uh, two-dimensional diagrams. Next, three-dimensional diagrams, right? So three-dimensional diagram means they have 3D, right? I mean, three dimension. What are those? Usually in mathematics, we have three coordinates, like say x, y, z. Say x, y, z. See here, they have always three directions. Three directions. Example, cube. Example is cube. To look, those diagrams are in three-dimensional, right? So cube, it is very hard to show the diagrams by in 3D by manual method. Cube, then uh, globe, right? So like a cricket ball or like a globe, right? Globe. So these are what three-dimensional diagrams, right? Then pictogram means pictograms are nothing but representing the data in the form of pictures, right? So representing the data in the form of pictures. So these are what some different types or different kinds of diagrams, right? So in next video, we'll discuss about first one, that is one-dimensional diagrams.